back at the IR. Let's double click Spectrum, get that open. While it's opening, let's check to make sure our zinc selenide crystal looks clean on the ATR adapter, and it does. I was the last one to use it, looking good. Make sure my anvil tip is screwed in well. It is. I haven't used the IR in a few days, so I'm going to do my instrument scan background just to make sure everything looks good, and say OK to the default parameters. See how she goes. Should look like this. Remember, this is a normal background scan. We've got carbon dioxide, water vapor, plastic inside the instrument, and it's looking like that. It's looking good. Overwrite to save this as the new background. It looks good. And now I'll actually delete it, so when I run my sample, it won't have the background up there. So let's put sample on here. So I'm going to get a little bit of my Fluorenol, what I believe is Fluorenol. Okay, I've got much more than needed, but that's fine. I think I have enough for what I want to do. I can put that on the zinc selenide crystal, kind of push it down a bit. There it is. Feels like the consistency of cotton candy. Alright, so now I have to crush it down with my anvil because it's solid. It won't get good contact with the zinc selenide crystal unless I do. And when I do this, I have to have it down all the way till I just see a little silver lining right there. Okay, now let's go scan it. So we did scan background the last time. This time we go instrument scan sample. Okay. And so I expect the alcohol signal, sp3 carbon hydrogens and sp3 carbon hydrogen and sp2 carbon hydrogen. Let's see if we got it. It's asking me to overwrite it. 4 scans were taken. Let's overwrite the last scan sample. It looks good. I see an OH here. Alcohols on solids don't normally have as nice a parabola shape as liquid alcohols. So let's go to, let's actually get this guy off the baseline. I don't like it when it's touching the baseline. It looks like maybe you're hiding something. So I have to just push up on the bottom of the screen for a little bit, and then I tap the top. And sometimes there's a delay, but boop, see, that's what it did it. So it squeezed it, there we go. And now I'll bring up my vertical cursor button. You just click to bring it on, and here it is, see the green line. And you can click to turn it off, and then on again, off again, on again, and why would you turn it on? So here we go, we're going to put over alcohol. Look at 3,300, that looks like an OH. And then what's this one here? Oh, over 3,000, that looks like sp2 carbon dihydrogens. This one maybe? 2920, that might be sp3 carbon dihydrogen. It's a little bit too far. That's it right at 3,000. I don't know about that. That didn't look like much anyways. It looked like the side of the other one. But I think this looks pretty good. We got some peaks over here. We'll look up this, see if this is on SDBS or another website online, this molecule. Fluorenol. Oh, you know, yeah, I'll do that. Look it up on SDBS. And then I'll put a text box on there, and I'll collect this data for you. As always, I want to clean off my sample. So I lift up the anvil. Get a chem wipe. Wet it with a little ethanol. And then grab off that solid with the wet chem wipe, and off of the tip as well. And do that a couple times at least to get all that solid off of there, and then do a dry one. Now I'll weigh out some of the Fluorenol for an NMR. NMRs, so I've got a test tube which I labeled, Fluorenol, initials, date, and a Erlenmeyer, something just to hold it on the scale. Put that on the scale, and I'm going to zero this out, and I want to add about 0.1 grams of Fluorenol, if I have that much. So I'll take it back out and start adding Fluorenol to this, see if I got 0.1 grams or not of this cotton candy. Ugh. Get over there. There we go. I have a feeling it might be all of this is what I need. Let's try that much first. That's coming out to 0.26, so it's only about a quarter of 0.1 grams. So I think I'll just use all of this. It's actually, sorry, I can't talk. It's actually a good idea to save a pinch of your solid, just in case you need to do a TLC or something later, you have a little bit. So I won't use every bit of it, but also I don't have to worry too much about not using every bit of it if I only use methylene chloride. I'm not methylene chloride, but deuterated chloroform as my NMR solvent. Because deuterated chloroform evaporates very quickly, so I could just evaporate it away after the NMRs. But I'm thinking that if the deuterated chloroform doesn't dissolve all of this, then I might go get bottle service. Go to the VIP room and get the deuterated Dmso. But here, let me just get this much. I'll leave that last little bit in case I want it for something else. Let's see what we got here. 0.677. I'm just going to go with that 675. Yeah. Let's add some deuterated chloroform to this. I want to add the deuterated chloroform to about 0.5 centimeter height, so I've got that black line there showing me. That's 0.5 centimeter. Okay, I've got my deuterated chloroform. Let's see if you can read the label here. Yep. Chloroform D, 99.8% isotopically pure. It contains 1% TMS. Deuterated chloroform and pushing it back out. Doing that a couple times to evaporatively cool the pipette, so I don't have it squirt out on me on accident. And I want to add just enough to get to the 0.5 centimeter. So let's see where that will get me. That's about not quite there. This cottony solid kind of sucks up the solution. Yeah, I think this is going to work good. I might have added a little more than I wanted, but not too bad. Let's hold it up against here. What do you think? That's looking pretty good. Shake it around. Looks like it all dissolved, huh? So if I had more, I would probably add more. I think I see maybe a little solid in there. But I might add a little more solid to kind of oversaturate it. And once again, I added too much deuterated chloroform. I should be more careful with that. It's hard to do when I have the phone in my way while it's videoing. I'm making excuses, but it's just a lot easier to do if you don't have to video it. But here, let's put this in an NMR tube in a minute. I'm looking at it a little more, and I feel like there's a fair amount dissolved in there, so I'm going to do the bottle service. I'm going to put a couple drops of the good stuff, the deuterated Dmso. So this one's the, focus here. Dimethyl sulfoxide D6. 99.5 isotopically pure, C2D6O6. So it's 99.5% that molecular formula and 0.5% D5H1. Okay, so let me get a pipette for that. Okay, I drew up some deuterated Dmso, pushed it in, did that a couple times. Now I'm just going to do drops, so I'm going to be careful about this. One drop. 2 drops. Let's see how that looks. Does it look like it's clearing up? Yeah, it looks like it cleared up. I'm going to do one more drop. Where's my camera? Okay, there it is. Well, I'm going to do that. That was like half a drop. Okay, so swirl that around. Yeah, this looks completely dissolved now. Just a little bit of the expensive deuterated Dmso. Now we have a not saturated anymore, but we have a more concentrated solution. So let's fill up our NMR tube with that. Okay, time to fill up my NMR tube. I took an NMR tube and I labeled it. It's kind of hard to read. It kind of says Fluorenol, but in pencil. And then I made a line at about 4 centimeters up. It needs to be at least 4 centimeters high. And I made a little label for it I could stick through to help me remember what it is. So now I just need to pipette that into the NMR tube. Drop some of this. This is going to be more than enough because I went over the 0.5 centimeter in the test tube. no, actually, that's still a little bit below 4 centimeters. I think that's actually high enough because I think you can get away with like 3.5 centimeters if you don't have a lot of sample. And now I'm over 4 centimeters, and that's fine. Yeah. And I've got here a nice white cap. It's a white cap party. Here we go. Cap that. Got the cap. There we're good. And I'll put my label on it, like so. Bring it over and get the NMRs. Time to get the sample spinning. Let's put it in our spinner. Ooh, this NMR tube's kind of tight. Shoot, sometimes they're bigger like this. That's annoying. Okay, so as things go in lab, often that last NMR tube was not manufactured well. It was a little too thick, so it wouldn't stick in my spinner. So let's try this one. Yep, this one's good. And that happens sometimes. These NMR tubes we buy, I buy the inexpensive ones. They're like $1 or $2. Still cost you some money, but there's some that are much more expensive. They're made more specifically. So here we go. I've got it in this spinner at the right height in the new NMR tube. It's floating. I'll hit the off button. It'll drop down, and now it's not spinning. But when I turn it back on the air, it should start spinning. Yes, I can see it spinning. There it is. See that wobble in it? That little wobble is called the camber. How much it wobbles is not that big a deal for our 60 megahertz NMR, but for our, the higher magnetic field NMRs, 300, 400, 500, they want to have less camber. They'll give you better signals, and so you have to buy more expensive NMR tubes that are more symmetric. But with our 60 megahertz, the cheap ones work fine. Sometimes you get a dead though, like I just got. So I'm in H1 NMR. 0 go. ZG, enter. Enter, and we're scanning. We're gonna see what it looks like while it's doing its first scans. Let's draw it up and predict what we should get. So here it is. Oh, the scan is done. Let's bring it over into nuts, and then I'll keep drawing it up. Okay, and the command to bring it into nuts is the letter A and the number 2. There it is. It's looking a little dilute, but I think this is looking good. Ooh, coupling through the alcohol. Interesting. Yeah, doublets. Cool. Huh. All right. Well, it looks a little dilute, but we'll just go with it. But I'm gonna shim it. It looks like TMS. That looks pretty good. I'm gonna shim it anyways, and then set the TMS to 0. So I'll do the shimming first. To shim, I just type SHIM, hit enter, relaxation delay of 2 seconds, enter, and I'll let it shim. It's going to be shimming the electromagnets around the sample to make the sample as homogeneous as possible. It initially adjusts the receiver gain. Now it's shimming electromagnets C and Y. Okay, while we're waiting for it to shim, let's do some predictions. So the phenol, I would expect it to be a 1 hydrogen singlet, but it looks like it's a doublet, so it must be coupling through the oxygen, again, like our last one. That doesn't usually happen. That's a 1 hydrogen, I would think would be a singlet, but it looks like a doublet. And then we have these are equivalent. The 2 ortho to the 5-membered rings carbon with the alcohol, and then these 2 are equivalent. It's probably tempting to think they're different, I don't know. But anyways, this is what it is. These 2 are equivalent, and then these 2 are equivalent. Okay, so we got those groups. This first group here, that should be a 2 hydrogen triplet because it has 1, 2, 3 bond neighbors, a couple of those, and then 1, 2, 3, 4 bond neighbors, but they go through half a pi bond, so it's close enough. So 2 different neighbors, not equivalent triplet. The next one is a 2 hydrogen, let me see, it can get this neighbor for 3 bonds away, that neighbor 3 bonds away, that's 4 bonds away, but half a pi bond, half a bond, yep. 3 neighbors, not equivalent, quartet. And then the final one is like that top one. It's going to be a 2 hydrogen triplet. Sorry. 2 hydrogen triplet. Question mark there. Wait, 1, 2. Oh, and I missed one. This middle one, 2 hydrogen quartet. There we go. But they're really going to be just a big mess in the aromatic region between 7 and 8. So here's my first scan of the proton NMR. It looks like I got doublets, which is cool. I'll explain that later. I'm not sure what this is. This might be water or something. I don't know. TMS is a little off. It's at negative 0.120. So let me fix that. I'll go to AII and I'll type FO frequency offset. Type FO there, hit enter, and it's going to ask me where is TMS now. It's at negative 0.120. Is that what it was? Let me double check. Yes, negative 0.120. So let's go back to here. So it's currently at negative 0.120. Hit enter. I want it at 0. Enter. So now when I rescan, it should look good. Z, G, enter, enter. Waiting for the FID. There it is. Go to nuts, type A2, and there it looks good. Let's see where it is now. If I hold this and type M. Oh, it's a, is it a doublet now? Let's see. Shoot. It wants to be shimmed. Not too bad though. I'm not going to shim it. It looks alright. I think that's water anyways. I don't know what that is. I don't know what that is. And then, yeah, I'm gonna go with it. Alright, so it's not too bad. Let's zoom in on the main peaks. I'm in the zoom subroutine now. I gotta get out of it. Enter. And then I will add a text box. Does anybody know the commands to add a text box? No? Yes. It's NO. So now I'm in enter notes subroutine. And then I have to hit A to add one, so I'll type up a nice text box and get right back to it. Okay, I typed up my text box, and I'll hit OK, move it somewhere here, and then I hit enter to get out of that text box subroutine, get back to the base level. The next thing I want to do is integrate. To integrate, the command is ID. And my integral curve is cut up from the last time I integrated. So what I want to do is type the letter C, and it clears all those codes. And then what I'll do is I'll double click here and then click in between those 2 aromatic clusters, maybe like here, and then double click again, single click, and then on this doublet, double click, single click, double click. Oh, I triple clicked. I gotta click one more time, I think, to get a, yeah. I got now type L to erase that last one. Okay, here we go. Double click, single click. I don't know what this is. I'm going to integrate it just out of curiosity. Single click. Yeah, let's see what happens. Okay, now I'll assign a value to one of them. So I think these are the 1 hydrogen alpha to an oxygen and 1 hydrogen alcohol. I don't know which is which, but I'll click once on one of them and then I'll type the letter V and I'll assign a value of 1. Hit enter. So now this one is my reference. Oh, I got that extra little funky thing. I don't like when I get those. Let me click that. So if I type L, I can delete the last one, last one, last one. Okay, let me get this one again. 2 clicks, 1 click. 2 clicks, 1 click. Click once, type the letter V, assign it a value of 1, hit enter. So this looks pretty good. I got a 1 to 1 to, I don't know, 3.5. Maybe I should have cut that part into this side. Let me try that. I'm going to click once on this and type D. Delete that one. Click once on this and type D. Delete just that one. And then I do 2 clicks here. 1 click there. 2 clicks here. Oh no, it's looking the same. Huh, it just switched. I wonder if I ignore that. How many hydrogens should I have in the aromatic region? I need to have 2, and then another 2, another 2, another 2. So 2, 4, 6, 8. I need 8 total. I wonder how these would be split up to make 8. They need to be 4 and 4, huh? Seems like, oh wait, maybe I, no, it's just delete this one. Delete that one. 2 clicks, 1 click. That's about 4. 2 clicks, 1 click. Getting closer. All right, I'll go with that. So it's about 4 and 4, 1 and 1, and I don't know, 2.6. I don't know what is causing that. So we crystallize it from ethanol. I don't think it's that. Some deuterated Dmso that has a water signal right here, probably. It's got a little bit of deuterated Dmso. I don't know what this impurity is. Oh wait, no, fluorenol. No, I'm not sure, but it looks like we do have fluorenol here. So I'll just capture this data for us. Oh, and then while I'm capturing that data, I'm going to start the carbon scans. So I'm going to go over here to the carbon NMR, and I'm going to type NU space C13, enter, and now we're in the carbon setting. And I don't want to do the normal 12 default scans. Here it says 1 out of 12 scans. I'm going to change it. I'm going to do more because our sample's a bit dilute. I'm going to do an NS space 30, and then hit enter, and now it's going to do 30 scans, not just 12. So to start those scans, I just type ZG, enter, and I'll let it go. We're almost done, 26 out of 30 scans. While we're waiting for the last few scans, let's predict how many carbon signals we should have. So we should have this one for sure, right? That's 1 signal, 2, 3, and then these guys, it's going to be a number of them. I can do this guy, it's getting kind of ugly. And then I'll take these 2. And finally those ones. So I'm expecting 1, 2, 3, 4, 5, 6 aromatics and 1 alpha to an oxygen. So the scans are done. Okay. Let's bring it over in nuts. So remember the way you bring it into nuts, it's not the same as proton. It's not A2. It's you have to hold the control button and then press F3. Top here, F3, and it'll ask you, do you want to open the default carbon? Yep, that's what we named it. And then line broadening is 0.5, enter, and then OK at that point. And now, ooh, it's a dilute sample, so we got a lot going on here. Let's type M to get those values a little more manageable. Shrink this up. Ooh, it came out funky, like it needs. Phasing's not good. This happens sometimes. Let me phase this. This is something you'd normally do. I'll highlight this area, type 1. Sorry, Siri decided to ask me if I needed help in the middle of my video. So here we go. I'm going to highlight that other area, type 2. I hit enter to get out of zoom, and then I type PE to phase these guys. So this one, I can go like that. This side, go like that. I think that's the alpha to the oxygen. All right, so done with the phasing. Yeah, so it's better. Let's go from 0 to 200. And, oh, I forgot, I'm going to do a meta object. So I'm going to zoom in on this area. A little tighter too, so you see this show nice. And then I'll do the minimum peak heights for them. Take away this table. That table's annoying. And then I'm going to type the command mo meta object. And I'm going to add it a. So what it is, it's this screenshot of where I zoomed in. So if I exit MO, I can zoom back out. So 200 to 0. And then I can enter MO again. I can move this box and stretch it out as much as I want. I'll move it over here, maybe make it big. Oh, come on. That's kind of nice, right? And then exit MO, and I'll hit M to get minimum peak heights like that. This guy's overlapping, that's annoying. View, clipboard text, peak labels, take them away. I still like those peak labels. Go back into MO, make this guy a little smaller. There it is, so he's not like overlapping labels. You see how the other peak labels are. Well, actually I'll keep that one, what do we do? Just barely get those guys. What do I get?
I think that looks pretty good. So I was expecting 6, 7 signals. Maybe I'm getting 6. That's not bad. So in this region, I feel like that's a real signal. It's like, so it's 1, 2, 3, 4, 5. So I'm missing one of my 6, and I think this one might be the alpha to the oxygen. It's between the two enzymes. Okay, so now I just add a text box, NO, A, and then I'll type that up and share it for you guys.